If you have not yet watched the video over differential equations, I would suggest starting there before you watch this video on slope fields. So slope fields deal with creating basically a pattern or a guideline for how we're going to graph differential equations. So we have a differential equation, y prime equals x plus y. Okay. I'm also given what's called an initial value, or we could call that a starting point, initial solution, something like that, right? So initial value problem here, I've got y of 0 equals 1. We're going to use that later. I want to focus in on our differential equation, y prime equals x plus y. Now, if I said create a graph for that, you probably wouldn't know where to start. So what you do when you graph differential equations, and you represent those on a graph, you create what is called a slope or direction field. And that is simply going to be a grid that's going to say, hey, all of the solutions, so remember differential equations, our answers are solution sets. We get like a family of solutions. All of our solutions are going to fit this slope field. And we're going to graph maybe one specific one, and that would be what this initial value problem would be. But I want to first create like a guide that all of those solutions would fit. And that is what a slope field is. So how do we create this slope field? What does that look like? So our differential equation here is y prime equals x plus y. So remember, from way back, okay, when you first learned about derivatives, whenever that happened to be, y prime, the derivative, tells you the slope of a tangent line, right? So when we see y prime, we should always be thinking slope. Slope, right? So the slope at any given point, at any given xy point on this grid, is going to be given by, in this case, in this equation, the sum of the x and y coordinates. So what I'm going to do is just pick some points. Let's say I use the point 0, 0. If I plug the point 0, 0 in, plugging in 0 for x and 0 for y, it would tell me that at the point 0, 0, y prime would be 0. Well, what does that mean? That means the slope of my tangent lines at 0, 0, that's going to be 0. So a line with a slope 0 is completely horizontal. Now, what I'm going to do is I'm going to indicate that, because that was just at that one specific point, I'm going to indicate that with a small little strictly horizontal hash mark there to represent slope of 0 at the point 0, 0. Okay? Well, let me try a different point. So let's say we go to the point 1, 0. Well, at 1, 0, y prime would be 1 plus 0, which would be 1. So the slope of the tangent line at 1, 0 is positive 1. So I want to indicate positive 1 slope at that point, which means I would have a line that would have a slope of positive 1, right? So up and to the right, slope of 1. What 2, 0, my slope would be 2 if I use that equation, plugging in 2 and 0. So I would have a little hash mark here that's a little bit steeper than the one I had at 1. And at 3, it would be steeper yet, and so forth. And as I work out from that 0, 0, these hash marks on the positive x-axis would continue to get steeper and steeper and steeper. What if I went the other way on the x-axis? Negative 1, 0. Well, negative 1, 0 would give me a slope of negative 1. So that would be like that. And then negative 2, a little bit steeper. And negative 3, a little bit steeper. And more steep as I go out to the left here. Okay? So in order to not have this be a super tedious process, you kind of want to look for some patterns that you could go by. And if my differential equation is simply just the x-coordinate plus the y-coordinate, I want to think about what the sum of those things would be. So if we have the same number for x and y, but one is positive and the other is negative, then we would get 0, right? So like 1, negative 1, 2, negative 2. All of those points would give me slope of 0. So if I think about that, all of those points where the x and y are the same number, but one is positive and the other is negative, those are all going to have a horizontal tangent line. Right? So I have that whole diagonal where I've got horizontal tangent lines. Well, if we think about points where they're different in sign and the positive one is 1 more than the negative, then they're going to add to 1. Right? So I've got that at 1, 0. I could also say at 0, 1, it would also be positive 1 here. But like 2, negative 1. Right? 2 plus negative 1 is 1. 3 plus negative 2 is 1. Negative 1 plus 2, negative 2 plus 3, negative 3 plus 4, all of those are slope 1, and I start to see these patterns, right? That's what I want to look for. If I go diagonally above that, there's going to be all slope 2, and diagonally above that, all slope 3, and so forth. And as I get further to the top right of this graph, I'm getting steeper and steeper and steeper until those are going to be basically a vertical line, okay? Now, not technically vertical, but they're going to be so steep that with these little hash marks, it's going to look vertical. And then if I go below this, and I start to look, well, what happens if I go down into the left? What kind of patterns do I see here? Well, all of these would have slope of negative 1. So they're kind of all the same through here. And then all of these would have a slope of negative 2, so a little bit steeper negatively than what I just had. And then all of these would have a slope of negative 3, so steeper yet, and so forth. So I'm going to keep filling these in, but the idea is they get steeper as you go down to the bottom left. Until, again, those become essentially vertical. And again, I'm going to do the same thing. I'm going to make these be steeper in the positive direction as I go up, but then, again, steeper and steeper as I keep going up on this diagonal until we get to the very top up here where it's going to be essentially a vertical line. Okay, and we see this slope field. Now again, I could expand this out. I could make this more of a tedious process. All I did was go 4 units in each direction, but I could go infinite units in each direction. I could make this slope field be as large as I want it to be. But I want to just kind of see what's going on around the origin and what direction that tells me to make my graphs. Okay, so now we're going to look at that initial value problem. So that initial value problem said y of 0 equals 1. So what that tells me is that I want to incorporate the point 0, 1. So where's that? That's right here. If I wanted to represent the single solution to this differential equation where I go through the point 0, 1, I have to follow these hash marks to make my graph. Now, following the hash marks is essentially like keeping your graph kind of parallel to those things, right? So as I go off to the right, I can tell I'm just going to be going up, right? All those hash marks are telling me, hey, the further right you go, the more vertical you get, so go up. As I go off to the left, initially, because at 0, 1 it's going down, initially I'm supposed to go down. But then I run into this diagonal wall of horizontal tangent lines. So that tells me that my graph's going to go down, but then it's going to bottom out. And then where's it going to go? Oh, well, now I have this slope of negative 1 where my graph is just going to become essentially parallel to that. And I get this graph of the specific solution where I had the point 0, 1. Okay? And that graph is going to change for each one of those differential equations that would be a solution. So I want to be aware of that. Okay, that slope field helps me to graph all of those solutions, whichever one I want. I can use this slope field to graph it. But what's going to happen is they're all going to be fit into this field or this direction field. Okay, and that's what this bottom line says here. You can draw the curve by making sure to keep it parallel to nearby line segments. And that's exactly what we did. Desmos does a really nice thing. They have a slope field generator that someone created here. So it says let g of x be dy dx. So g of x is representing our derivative, y prime. I just graphed the one that we just did here on this video. So x plus y. And our slope field looked like this, right? We've got these horizontal tangents diagonally, and we just see those patterns. There's a movable point on here. So if I did that initial value problem at 0, 1 right here, notice how if I go off to the right, it's telling me go up. And as I go up, it's saying go steeper up. And that's how I made that go up and to the right. If I go to the left, it initially says, hey, go down. So I go down, I bottom out, and then I start going up this way. And that is what that problem looked like when I graphed it, given that slope field. Okay, so this slope field generator really is nice because it helps you graph any slope field and represent that. All you have to change is this part of the equation. As long as you have y prime by itself over here, you're just changing the right side of your equation, and that will create a slope field for you.